Today we study about the center of mass of a system of n particles under our main topic, dynamics of rigid bodies. So let's start from dynamics of rigid bodies. Our topic is center of mass of a system of n particles. Center of mass of a system of n particles. For this, we can assume n particles having different masses like m1, m2, m3, and so on. This is for x coordinate. This is for y coordinate. This is origin. Coordinates of origins are 0, 0, 0, and so on. Let us suppose at R1 position vector there is particle M1. At position vector R2 there is a particle M2. At position vector R3 there is a particle M3. At position vector R4 there is a particle M4. At position vector M5 R5 there is a particle 5 having mass M5. So as shown in our figure, let the masses of n particles of a system be, let the masses of n particles of a system m1, m2, m3, so up to mn, and their position vectors related to origin respectively, and their position vectors relative to respectively be r1, r2, r3, so on rn. Let rcm will be the position vector of center of mass of this n particle system. Position vector of center of mass of this n particle system, where total mass, say capital M, equals to m1 plus m2 plus up to n, situated or lies concentrated on that, is supposed to be concentrated. Let f1 dash, comma, f2 dash, comma, f3 dash, up to fi dash, and up to fn dash be the respective external forces acting on the particles. Respective external forces acting on the particle. Each particle of the system experiences internal forces also. Each particle experiences internal forces due to rest of the particles, due to rest of the particles. Therefore, total internal force on, therefore particle internal force on ith particle of the system. Ith particle of the system will be Fi double dash is equal to Fij double dash j plus 2 equal to j plus 2 small n, where j is not equal to I, I. Here Fij is the internal force on ith particle. Here Fij internal force on ith particle of the system due to jet particle. So total force acting on ith particle will be total force acting on ith particle will be Fi is equal to therefore total force capital F acting on the system will be total force acting on the system will be I is equal to 1 equal to Fi dash plus I is equal to 1 to I is equal to small n Fi double dash. Here Fi double dash from I is equal to 1 to I is equal to n will be 0, as sum of all mutual internal forces acting between the particles of the system is 0. Acting between the particles of the system will be 0. So I is equal to 1 to I is equal to n Fi dash. This is our equation 1, let us suppose. That means relative force acting on the system is sum of relative force acting on the is sum of external forces acting on all the particles, according to Newton's second law now. According to the F will be d by dt of Vn, or in other words we can write I is equal to 1 to I is equal to m will be a constant, so it will be out d by dt of Ri square, or we can say like d square by dt of d square of dt square of I is equal to 1 to n, I is equal to 1, or we can say d square by dt square, d square by dt square of I is equal to 1 to I is equal to n MIRI. Now motion of center of mass of mass of the system of of particles is such that is such that the total mass of the system total mass of the system is concentrated on it is concentrated on it and overall force factor acting on all the particles all the particles is applicable on center of mass itself. So F is equal to d square RCN dt square. By equations 2 and 3, what we have m dt square is equal to m d square I is equal to 1 MIRI upon capital M, or we can write position of center of mass will be I is equal to 1 to I is equal to n MIRI on capital M. On releasing the whole equation, what we can write or RCM is equal to M1 R1 plus M2 R2 plus M3 R3 plus MN RN M1 plus M2 plus if all the particles have same identical mass small m, then if M1 बराबर M2 बराबर same identical mass m, then what we can write? We can write RCM is equal to R1 plus R2 plus Rn upon. So that means position vector of center of mass having particles of equal mass is the average position vectors of all the particles. That's it. In next class we will get the Cartesian coordinates of center of mass in x, y and z dash. Thank you.